It isn't always easiest or even possible to integrate everything using basic integration rules and techniques. Sometimes when we take the derivative, we had to have used the chain rule. And so the chain rule is a derivative process. U-substitution is the equivalent integration process, where U-substitution undoes the chain rule. For a moment, the integral of x times dx. Now, one option we have, which I'm not going to explore, is I could expand out x squared minus 1 to the 6th, then multiply everything by x, and then integrate using my basic rules. I don't want to do that if I can help it. So instead I'm using U-substitution. And what I'm looking for is a relationship between the multiple parts of this function. Specifically, I have x, and I have x squared minus 1, and I have something to the 6th. And what I notice is that the derivative of x squared minus 1 is x to the first. And so I'm going to set u equal to x squared minus 1, because x squared minus 1's derivative is related to x. The derivative of u is u. The derivative of u. The derivative of x squared minus 1 would be 2x minus nothing, just 2x dx. As I took the derivative with respect to x. In my original integral, I said I have x and dx. Now I have 2x dx. If I divide both sides by 2, I would get 1 half du equals x dx. Now I have all of the parts that have x's in them, and I can make substitutions that have u's in them. What I mean by that is this integral is equivalent to u to the 6th, because u equals x squared minus 1. I know that x dx is equivalent to 1 half du. So my substitution of 1 half u to the 6th du. Now I'm going to take the integral of this function with respect to u, which is nice. The only variable there is u, and I can use the power rule to do that. This must have come from something to the 7th power. And I know that if the coefficient out front was 1/14, if I were to take the derivative, I would drop the 7. This would give me 7/14, which reduces to 1 half. 1/14 to the 7th plus c. And since my original problem started with x's, I'm going to go back to x's. I know that u equals x squared minus 1. And so the integral of my original function notice that if I were to take the derivative of this using the chain rule, it would be the derivative of the whole thing. Drop the 7, so 7/14 x squared minus 1 to the 6th times the derivative of the inside. The derivative of x squared minus 1 would be 2x. The derivative of the constant is 0. And when I multiply 7/14 times 2x, I end up with x times x squared minus 1 to the 6th, which checks out.